Okay, let's unpack this. We're diving into a really fundamental challenge facing AI agents right now. How do you build a memory that actually scales?
A memory that learns.
Exactly. One that learns over time and doesn't just, buckle under the weight of all this information. Because traditional large language models, they just hit a wall with context limits. We need something different.
We need structure.
We need structure. And today, we're attempting a true shortcut for you,
Hey.
a deep dive into a single, pretty technical source. It's the GitHub repository ReAME for a project called MemU.
It's billed as an agentic memory framework from Nevermind AI.
And our mission here is to really clearly define how this framework takes all this raw, messy input and turns it into structured, intelligent, and most importantly, usable knowledge.
And it's timely too.
Very timely. We're releasing this deep dive on the very first day of their 2026 New Year Challenge, which runs from January 8th to the 18th. It's all about community contributions and PRs, so it's a perfect time to get your head around the architecture if you want to get involved.
What's fascinating here, and I think this is the key point, is that MemU is not just, proposing a bigger database.
No.
It completely redefines memory as a self-evolving system. The whole idea is that the structure that holds the knowledge is dynamic. It adapts.
It improves based on how the agent actually uses it.
Precisely. And that's the critical leap we need to move AI agents beyond those simple short-term contest windows and into something that actually looks a bit more like long-term human-like learning.
That distinction, a self-evolving structure, that's everything. So let's start at the very foundation, the blueprint. They call it the hierarchical file system.
And it's this architecture that keeps the whole system from just, crumbling under its own complexity. It's an incredibly logical design.
It's modeled after hierarchical storage systems. Right?
Exactly. But for abstract memory, they've defined 3 distinct layers. And understanding the role of each one is really essential to getting the whole picture.
Okay, so the very bottom layer, that's the resource layer, right?
Right. That's the raw data warehouse. It's the untouched input, the source of truth.
So like the full JSON chat log or the entire text of a document?
Precisely. Or the raw image and video files.
Mm-hmm.
The whole thing, before any real processing happens, it gives you that full verifiable context for everything else.
Okay, so then one layer up, we hit the item layer.
Mm-hmm.
So if the resource is the raw chat log, the item is what? The extracted nugget.
That's a perfect way to put it. Items are the atomic knowledge nuggets.
Yeah.
They could be a specific preference that the agent discovered during a chat or a particular skill it learned from a log.
So individual facts.
Individual facts, relationship notes, opinions.
Yeah.
These are the building blocks that are going to be queried for specific answers later on.
And then at the very top, the highest level of abstraction is the category layer.
And this is where it all comes together. This aggregates all those lower-level items into structured, summarized text files. The source gives great examples, like preferences.md or worklife.md.
This nesting is what makes it so powerful. And for you, the listener, you should care about this because it delivers 2 huge advantages. The first is what they call progressive summarization.
Yeah, let's break that down. In practical terms, think of it like a massive archive project.
Yeah.
The resource layer is your giant digital library. Every single document you've ever saved.
Okay.
The item layer is like the specific index cards or the detailed notes you took on a topic inside those documents.
Right, the key points.
And the category layer.
Yeah.
That's the high-level executive summary you write for your boss that tells them the main themes without them having to read a single note. It's progressive because the agent can jump straight to the summary first.
So you don't start reading chapter 1 if you just need the conclusion.
Exactly. And the second benefit, which is just as important, is full traceability.
Which means
It means because the structure is so well defined, the agent can track every single item or category summary all the way back to its exact origin in the raw resource file. That traceability is, it's essential for maintaining accuracy and auditing the agent's knowledge.
that sounds incredibly complex to manage, though. If these category layers are constantly changing and the AI is reorganizing its own filing cabinet, doesn't that risk, data getting fragmented or confused?
That's a great question, and that's where the distinction between item and category is so crucial. The items, those nuggets of knowledge, they stay discrete. They're stable.
Okay, so the facts don't change.
Right. It's the category structure, the high-level groupings, and the summaries. That's elastic.
Yeah.
The algorithm is built to optimize access to the items, not to alter the items themselves.
We've got the intelligent filing system down. Now, what files actually go into it? Because the real world isn't just tidy text documents.
No, it's conversations, images, audio, It's messy.
It's very messy. How does MemU handle all of that diversity? This is the multimodal magic piece.
The strength here is its pipeline. It's built to standardize all these different data types into that same unified hierarchy we just talked about.
And that means specific models for each input type.
Absolutely. So let's run through them. If the input is a standard conversation, say a JSON chat log,
Right.
the system is actively extracting semantic relationships. It's not just saving the transcript, it's using an LLM to identify things like the user prefers coffee over tea. That becomes a specific item.
Okay, and for plain documents, text files, that seems more straightforward.
It is. That's more traditional knowledge extraction, pulling out facts, skills, domain knowledge. Simple enough.
But then you get into the really complex stuff, like images.
Right. And here, MemU doesn't just store the image. It uses a sophisticated vision model to generate a rich textual description of what's in the image.
So it turns what the AI sees into text,
Exactly. And that text description is what gets structured into an item. It becomes searchable memory,
which then leads right into audio and video processing.
which is a multi-step process. You need transcription to turn speech into text. For video, you need to extract frames, and then those frames get run through the same vision analysis as a whole sequence of models.
But the core result of all that work is that everything, text, conversation, audio, images, it all ends up in the exact same three-layer structure.
And that unification is absolutely crucial. It's what enables what they call cross-modal retrieval.
Which means the agent has a depth of context that was, well, basically impossible before.
Totally. Imagine an agent is asked about a difficult relationship. It can connect an item from a chat log, user expressed frustration with X, to a visual item from a photo the user shared a month ago that showed some nonverbal cue of that frustration.
Wow. So it's connecting an emotional insight from text with visual context from an image.
It's connecting the dots across sensory inputs. It leads to a much richer, much more human-like understanding of the world.
Okay, we've arrived at the engine room. This is the truly distinctive technical feature of MemU, and it's what you really need to grasp, the dual retrieval methods.
This is where we see efficiency built right into the query process itself.
Because the framework doesn't just have one way of thinking. It understands there's a trade-off between speed and depth.
Yes, the AI strategically chooses how to remember based on the query. It has two distinct strategies, and the agent decides which one to use.
Let's start with the fast one, the speed dial option.
That would be the RAG-based retrieval augmented generation. In the query, you specify method RAG.
And the mechanism here is fast embedding vector search.
Right. It's using cosine similarity. To put it simply, the AI converts the query and all its memory items into numbers, into vectors. And then it just looks for the nearest neighbors, the closest matches.
So this is your fast, cheap fact check. What are the pros and cons?
It's incredibly fast, and it's low cost. You can blitz through millions of items. The trade-off is the depth. It only returns results based on semantic similarity.
So it's got medium semantic depth.
Exactly. It doesn't involve deep reasoning by the LM itself, just similarity scoring. So if the question is, what kind of car did I mention last week? RAG is perfect.
But if the question is more like, given my budget, my commute, and my safety concerns, analyze and predict the top 3 cars I'm likely to buy, RAG can't do that.
No, it falls short. It can only pull isolated facts that seem similar. For that kind of analysis, you need the second strategy, LLM-based retrieval method.
And this is where the heavy lifting happens.
This is the heavy lifting, and you are paying for that depth.
It's slower, more expensive.
Much slower and much higher cost. But the payoff is deep semantic depth. The LLM is actively reasoning over the context it pulls up.
But to manage that cost and slowness, they've built in some efficiency tools. The first one is context-aware rewriting.
Yes. This is subtle, but so important. If you ask an agent, what did she say about that? Out of the blue, a normal search would fail.
Right. It doesn't know who she is or what that is.
But context-aware rewriting uses the immediate conversation history to resolve those pronouns. She becomes Sarah Smith, and that becomes the Q3 project report. It rewrites the ambiguous query into a precise one before it ever hits the memory bank.
That's smart. And the second tool is adaptive stopping.
This is all about capping the cost. It means the AI doesn't just search forever. During the reasoning process, if the model decides it already has enough high-quality information to answer the query, it just stops.
It stops the search early.
It stops the progressive search early, saves those costly API calls, and keeps things efficient, even in the expensive mode.
And there's another key distinction in the search scope, too. With the fast RGAE search, it's looking across all the items.
Yes, using vector distance.
But for the slower LLM search, it uses the category structure we talked about. It only searches within the relevant categories.
And that's the genius of it. By limiting the search to just, say, worklife.md and preferences.md, the agent dramatically shrinks the pool of data it needs to analyze. It makes that slower, more expensive reasoning actually feasible.
So, connecting this back to you, the learner, this dual engine gives the agent real cognitive flexibility. It's built-in cost optimization. It's smart enough to use a fast, cheap search for a fact and only deploy the heavy-duty reasoning when it's really needed. Let's pull this out of the theoretical and look at a couple of the practical applications they mentioned.
Okay, the first one is the obvious one, conversation memory. This is the bread and butter for any personal AI assistant or a complex customer support bot.
Right. It takes those raw JSON conversation files, and instead of just dumping them, it systematically extracts the preferences, the habits, the opinions.
And uses them to generate those summarized markdown category files. It turns every interaction into structured, reusable knowledge.
But the second use case, I think, is maybe more forward-looking, skill extraction from logs. This is about agent self-improvement.
This is huge. It involves processing the agent's own execution history. It looks at the actions the agent took, the outcomes, and it actively extracts what the source calls lessons learned.
This is incremental learning in action.
Absolutely. The memory evolves with every log file, successful or not. It generates things like updated skill guides or new strategic notes within its category structure. It's the agent literally reflecting on its own performance.
Which leads us to validation. I mean, all this elegant architecture is academic if it doesn't actually work.
And they provide strong objective metrics here. MemU achieves a 92.09% average accuracy on the Locomo benchmark.
Across all reasoning tasks.
Across all of them. So that's the objective backing that this combination, the structure, the multimodal processing, the dual retrieval, it actually produces reliable, accurate answers.
That is a powerful validation point. And just briefly, for anyone wanting to build with this, the ecosystem is modular.
Right. There's MemU Core, the pure algorithm engine. Then MemU Server, which is the back-end service with user management and all that.
And MemUE, the visual dashboard, so you can kind of pick your entry point.
Exactly. You can integrate just the core or deploy the whole thing.
So let's quickly recap the three big takeaways from this deep dive into MemU. First, the crucial innovation, that traceable three-layer memory structure, resource, item, and category.
Which allows the AI to manage overwhelming data complexity.
Second, the pipeline that unifies everything, images, audio, text, into that single hierarchy.
Enabling that robust, deep, cross-modal retrieval.
And third, the strategic advantage of the dual retrieval engine, the choice between that lightning-fast RAG search and the deep, reasoned LLM search.
Which strategically manages the complexity, time, and cost of every single query. This entire structure proves that the future of powerful AI isn't just about a bigger model.
No, it's about a better filing system.
An exceptionally better self-optimizing filing system. Which leads to a provocative thought. If AI memory systems can evolve knowledge based on usage, how might this very framework resource item category be adapted to help human learners, to help us structure and retrieve our own complex professional knowledge?
Using your email archive as the resource layer, maybe?
Exactly, and creating dynamic category summaries of your projects.
That's the question to sit with. Think about your own process for retaining knowledge. Are you operating on the RG level most of the time, that fast similarity search? Or are you forcing yourself into that slower, deeper LLM-style reasoning when you truly need to connect the dots? Food for thought.